Hello, this is Jeff Hamrick with the Financial Analysis Program at the University of San Francisco. I want to spend a couple of minutes computing normal probabilities and related things in Stata. So the two things I want to show you are the normal function and the inverse normal function in Stata. As is usually the case when you're doing computations like this, you need to put the display command in front of the command related to a probability calculation so that you can actually see the result that interests you. So for example, display normal, where I make 0 the argument of normal, confirms for me that half of the probability of a standard normal distribution is to the left of the point 0. If I just type normal of 0, it's going to say that it doesn't recognize the command. So you really do need that auxiliary command display in front of the phrase normal. So if I type in things like normal of minus 0.67, this tells me that under a standard normal distribution, about 25% of the probability is to the left of the point on the x-axis that's minus 0.67. Okay, so similarly, as you would expect with any probability distribution, if I type normal in a very large number like 10, since that for a standard normal distribution would represent 10 standard deviations to the right, I get a number that's basically 1. That means that virtually all of the probability mass is to the left of the number 10 on the x-axis for a standard normal distribution. So the normal command in Stata has a companion command called inverse normal, and you can use this command to find critical values if you're using the rejection region approach for hypothesis testing, or if you are trying to look up critical thresholds for a confidence interval that whose estimator has a z distribution. That doesn't happen very often in this class, but let me go on ahead and show you how to look up those numbers. So you have to again use the display command, but now you use inv normal. And for example, typing in 0.05 will give you the value on the x-axis such that 5% of the probability mass under a standard normal distribution is to the left of that value. So that value in this case is minus 1.64. So another way to read what's on the screen now is that to the left of minus 1.64 on the x-axis under a standard normal probability distribution is 5% of its probability. Okay? So if I change this, for example, to 0.975, display inverse normal, what I get is the usual rule of 1.96, or roughly plus or minus 2 standard deviations. So another way to read this is that if I want to have just 2.5% of the probability mass above a particular value on the x-axis, the point on the x-axis that leaves 2.5% above that value, and therefore 97.5% to the left of that value, is the value 1.96. So this is how you can use Stata to compute normal probabilities, or the inverse of a cumulative distribution function for a standard normal random variable. And there are other videos on Blackboard and on my YouTube site that show you how to compute probabilities related to t distributions, f distributions, and chi-squared distributions. Thanks.